So, hello, my name is RJ, if you guys don't know, and I did my presentation on a disease called sickle beta thalassemia. And there it goes. Okay, so a description of basically what sickle beta thalassemia is. It's a combination of two different diseases, sickle cell disease and a disease called beta thalassemia. So sickle cell disease, you may have heard of before, it causes the healthy and round red blood cells to become more of a sickly, skinny shape, and that impairs oxygen binding and also impairs oxygen circulation throughout the body. And then beta thalassemia is a disease that reduces the normal production of hemoglobin. So hemoglobin is the exact protein that the oxygen binds to be transported around the body. So when you have abnormally shaped red blood cells and less hemoglobin, it kind of becomes doubly bad, compound bad, and creates this disease called sickle beta thalassemia. And so the main symptoms of this are anemia, or like a low level of red blood cells due to the two diseases, jaundice, or like a yellowing of the skin, shortness of breath because you have less O2, like less oxygen in your body. That would make sense. And frequent episodes of pain because these sickle cells are kind of like a barrel of monkeys, so they get really locked together because of the shape, and this clotting is painful. And so what I was talking about also with the clotting is that because they're in that barrel of monkeys type sickling shape, they can stick together really easily, and they can become lodged in the legs to cause things like a clot there and called a deep vein thrombosis, or a heart attack like a clot in the heart called a heart attack, a clot in the lungs called a pulmonary embolism, and the brain called a stroke, and all types of clot-based events. And so a little bit more, it's a hemoglobinopathy, so that's what I was saying, that hemoglobin is the protein that oxygen binds to be transported around the body, and so it's a disease of the hemoglobin. And there's varying levels of severity, it's not the same in every single person. And so the frequency of it, sickle beta thalassemia is a very, very rare disease, and as such, it's not very well documented. But it's two component diseases, so the sickle cell and the beta thalassemia that make it up. They are individually documented well on their own. So sickle cells in about 2 million people worldwide, which is relatively common for a genetic disease, but not in general. And beta thalassemia is relatively rare, even for a genetic disease. So it's about only 78,000 people worldwide. So it's very, very small if you think about a world with 7.8 billion people in it. And inheriting these two diseases together is like lightning striking, incredibly rare, which is why it's not well documented as many cases. So possible complications due to this sickle beta thalassemia, many patients require constant blood transfusions, and as to why this is because they don't have that normal functioning hemoglobin. So what the blood does, the outside donor blood, is infused into their system to try to provide a new flush of healthy hemoglobin and healthy red blood cells to try to help that oxygen production and circulation throughout the body. And so if it's severe or left untreated, this sickle beta thalassemia can be life-threatening. It could cause a lethal anemia, a very low level of red blood cells, low O2 circulation, and impaired organ function, and organs can shut down. Also, it lowers immune function and can open you up to acquiring more serious infections. And like I was talking about before, it can increase the probability of a clot-based event because of the weird sickling shape, like the barrel of monkeys, of the sickle cells, and they can get stuck together and cause clots, heart attacks, strokes, pulmonary embolisms in the lungs, all types of clots. And so the molecular cause of sickle beta thalassemia, it's caused by two separate mutations in this one HBB gene. So it's on the short arm of chromosome 11, the P arm, and so one of these bad mutations causes the sickle cell disease, and the other mutation causes beta thalassemia. So you inherit one of these from one parent and one of these from the other parent. And then when it comes together, that's you, and you have sickle beta thalassemia. And so a little bit about these two diseases on their own. So sickle cell disease is caused by a point mutation. So that means there's basically a change in a base pair, and it's a missense mutation. So at the 6th codon, it changes the amino acid for where it should be a glutamic acid, it changes to a valine, and that's how you know the sickle cell mutation has happened. And so sickle cell is also, it changes the protein, so it's this HBB gene produces a protein called beta globin, and beta globin is a big part of this hemoglobin protein that carries the oxygen around the body. So if that hemoglobin is misshapen, the red blood cell is going to be misshapen, and oxygen transportation is going to be impaired. So this is why these red blood cells are not healthy, and they can often die because they're sickle shaped, and they can often die prematurely, and this can cause anemia, so a low level of red blood cells, they can get lodged and cause those clots as well. So a little bit more about beta thalassemia. So this can be caused by things like a point mutation, an insertion, so inserting a base pair, deleting a base pair. Very rarely is it caused by a frameshift mutation. But this mutation can cause zero production of normal hemoglobin, maybe some normal hemoglobin, almost pretty much normal levels of hemoglobin, but only a little bit of deficiency, and so there's a range. And in this hemoglobin, what I was talking about before, it transports oxygen around the body. So you can see right here, the little blue dot is the oxygen molecule, and the white dot is the hemoglobin molecule. So that's what the oxygen basically hitches a ride to. And then the red blood cell is basically the car that transports these all over the body. So it transports the oxygen all over the beta and beta thalassemia is another hemoglobinopathy, which contributes to sickle beta thalassemia. So the mode of inheritance is they're both autosomal recessive. Sickle cell and beta thalassemia are both autosomal recessive. So they tend to skip generations, and so for this compound disease, one parent is going to give you the allele for sickle cell, and the other parent gives you the allele for beta thalassemia, and that's how it is inherited. So for children of a parent with sickle beta thalassemia, because it's incredibly rare for one person to get it, but to have two parents with it would be almost impossible, basically astronomical. But for children of a parent with this disease, severity of condition can differ. So if you inherit one sickle cell allele, you're called a carrier of sickle cell trait. So you're generally going to be asymptomatic, and very rarely would you show symptoms. And if you have only one beta thalassemia allele, this is causes a disease called thalassemia minor, which is very mild symptoms. You may have mild anemia, mild problems due to slightly lower hemoglobin production, but you will live a normal lifespan. And so naturally, one sickle cell allele plus one beta thalassemia allele gives you the sickle beta thalassemia. And so here's a little bit of a pedigree. So you can see on the left, you have that the first male who has sickle cell disease, the red square, and then his wife is a carrier for beta thalassemia. So you inherit one allele of each type from each parent, and then you can see the purple, their daughter right there, is going to be the one that has sickle beta thalassemia. So you can see sickle beta thalassemia, like most autosomally recessive inherited diseases, can skip generations. And also I wanted to make a note that if you do out this Punnett square from these two initial parents, you have a half chance of either being a carrier of sickle cell or inheriting sickle beta thalassemia. And so there are different options for genetic testing. This is mandatory at birth to be screened for sickle beta thalassemia, as well as sickle cell. And there are different types of genetic screening for sickle beta thalassemia. There's prenatal testing, where the doctor goes in and takes either amniotic fluid or can extract some cells from the placenta and test those genetically. And also there's newborn screening, so there's a little blood draw from the newborn's heel. There's carrier testing, so that, and also diagnostic testing. If the doctor suspects you have risk factors or may have the disease, that's just a standard blood draw, and then it's sent off for genetic testing. Additionally, so I wanted to go into a little bit about who can order these types of genetic tests. So a physician orders these, the prenatal tests, like before birth. They also order the newborn screening at birth, and upon suspecting disease or risk factors. This is all physician or PA, NP, whoever it may be. But also there's the direct-to-consumer genetic tests that are available for sickle beta thalassemia. So anyone can order these, and these are done by large companies like LabCorp, Quest Diagnostics, other private companies like that. Excuse me. So I wanted to go into a little bit about treatment options. There's no way to cure or reverse the disease as of yet, and treatment is generally very basic. So plenty of water, staying current with vaccinations, eating a balanced diet. So basically just trying to maintain your health in general. But in recent years, there have been newer treatment options that have been researched and implemented. So for example, blood transfusions are not as new, but that helps to influx the patient's system with a normal amount of hemoglobin. So if they have that lesser level of hemoglobin or impaired hemoglobin, like damaged, they can get blood from a different donor with healthy hemoglobin and try to improve their oxygen circulation around their body by receiving blood. Also, there's a new medication called hydroxyurea that can help lessen pain, reduce clotting, increase the lifespan, and that's looking very promising. And also there's gene therapy, so that's using stem cells to try to put new copies of that damaged HBB gene into the patient so that they make the protein correctly, and you don't have that impaired hemoglobin. You have normal hemoglobin production. So that's in a diseased individual. They would put the stem cells in, and that'd be an example of gene therapy. And yeah, so those are my references, and thank you for watching.